Alrighty, my friends, we're doing adding and subtracting fractions. This is a big one because we're doing two topics in one video, but we find it all in unit 3.4. And I'm doing the two together because they basically follow the same rule, which is that your denominators have to be the same. So if you're going to add or subtract with fractions, your denominators have to be the same. And the reason is because if I had half a cake and you wanted to take away a quarter of the cake, you couldn't just take away one because I only have one half. You'd take my whole cake away, and you know that would make me upset. So we have to have the cake cut up into the same size pieces, which is the denominator. So the denominator has to be the same. So let's see how we do that. So if you don't know how to make the denominator the same, you need to watch the video on equivalent fractions. Let's look, how can we do this? So we have to have the equivalent fractions and we have to make the denominator the same. So 3 and 5. The easy way is just to multiply by the opposite denominator. So for this fraction over here, I'm going to multiply by the opposite, which is 5. So this is times by 5. And for this one, it would be times by 3. Then I must make sure to rewrite my whole problem with the new information. So 1 times 5 is 5, and 3 times 5 is 15. 2 times 3 is 6, and 5 times 3 is 15. So now that I have the same denominator, now I can add. So what I do is I add the numerators and I keep the denominator the same. I'm not adding the denominators together. So it's like I've got 5 pieces of cake and 6 pieces of cake, which is 11 out of 15 possible pieces of cake. Okay, I'm not adding the denominators because I don't suddenly have 30 pieces of cake possible. I still only have the 15. So that's my fraction added together. And 11, only 1 and 11 goes into 11, and 11 doesn't go into 15. So, that's my simplest fraction. Alright, let's try another one. So another one we're going to add. So again, I'm just going to multiply by the opposite denominator. So times by 4, top and bottom, times by 3, top and bottom. Okay, so 2 times 4 is 8. 3 times 4 is 12, plus 3 times 3 is 9, and 4 times 3 is 12. So now they are same denominator, so I can add these fractions. So 8 plus 9 is 17, and remember I keep the denominator the same. Now this can definitely be simplified, and I notice that it's an improper fraction. Sorry. So I say, how many times does 12 fit into 17? That's only one time, and I have 5 over 12 remainder. In 5, the only thing that goes into 5 is 1 and 5, and 5 doesn't fit into 12, so that's it. Sorry. That's how we add these fractions. What about subtraction? Subtraction is the same idea. We need to make sure that the denominators, just like we did with addition, we need to make sure that the denominators are the same. Now I actually think I've got this the wrong way around, so I'm very sorry. We're going to go 3 over 4, take 2 over 3. Let's do 2 over 5 for fun. Make it different numbers. Sorry for all my coughing. Okay, we need to make them the same. So let's multiply by the opposite again, just to make life simple for us. 3 times 5 is 15. 4 times 5 is 20. 2 times 4 is 8. And 5 times 4 is 20. Now that we have the same denominators, we can just subtract. So 15 take 8, 7, and 7 over 20. The only things that go into 7 are 1 and 7 doesn't fit into 20. So that's it. We're done. We're finished. Now, what happens if we have mixed numbers? Two options, guys. You have two options. You can turn them into improper fractions, or you can put them to the side, okay? So we can add our whole numbers separately. So 4 plus 2 is 6. Oh, I should do it in black. 6 plus 5 over 6 plus 3 over 4. Alright, so we've just added our whole numbers separately. Now we add the fractions. And again, we have to make sure the denominators are the same. So I'm actually going to times this by 2, so it end up being 12, and times this by 3, so it end up being 12. I'm going to keep my 6 there, so my teacher knows I know that it's still sitting there. And this is going to become 10 over 12, and this is going to become 9 over 12. Now that I have the same denominator, I can add those parts together. So that is 19 over 12. So that's an improper fraction, so I can convert that into a mixed fraction. So that's 6 plus 1 and 7 over 12. Now I can actually go and add this 6 and this 1 together. So we actually end up with 7 and 7 over 12. So if you have whole numbers, you could convert them in, but it could make a really big improper fraction for you to work with. That's fine though. It's just as simple. But otherwise you can add the whole numbers together. And then when you get to the end, don't forget, if you have another additional whole number, you should add it in as well. This is the same as subtraction, except subtraction you might have to borrow as well later. So let's see what I mean. Let's start and we'll do this. 6 take 2. 6 take 2 equals 4. So I'm going to start with 4. Now, I'm adding this 5/8 because it was added to the 6 before. But I'm going to take away the 3/4 because that's the operation that's happening to it. Alright. Now I need to make them the same denominator. 4 can become 8, so I'm just going to times this one by 2. Keep the other one the same. So I got my whole number there, plus 5 over 8, and take 6 over 4. Oh, 6 over 8, sorry. I forgot to multiply. Now I'm presented with a problem. I've got 5 over 8 and 6 over 8. But I cannot do 5 take 6. So this is when we can come to our whole numbers and borrow from our whole numbers. So an easy way to think of it is if I think of 4 as 3 plus 1, and then I think of it as 3 plus 1 plus 5 over 8, take away 6 over 8. And then this one right here, I'm going to convert it into a fraction that's over 8. So that would be equal to 8 over 8. 8 over 8 is equal to 1, so I haven't really changed it. I've just turned it into a fraction. And I've written everything else that's left. Now, what's 8 plus 5? 13 over 8. And then that's 6 over 8. Now I can take 6 away from 13. So 13 take away 6 is 7 over 8. And now I've got 3 and 7 over 8. 3 and 7 over 8. Alright, so for calculating mixed number subtraction fractions, you could convert these straight into impropers if you want, and then you wouldn't have to do this double step. But if you don't want to, you can subtract the whole numbers straight up, but then you must remember that you're adding that first fraction, taking away the second fraction, and then if you need to, when you borrow, you turn a whole number into a fraction over the same denominator, okay? And then you can just finish it out. If you're confused by that, please ask your teachers. But that is how we add and subtract fractions. So you must remember, always, always, always have to have the same denominator. Awesome.